Hello, let's continue with question 3. Now, I've decided we'll take a break from the junior round and let's go to the senior round. Basically, the senior round is for 15 to 16-year-olds. But this question will still utilize the same formula. Root 10 minus root 2 to the power of 1/3 times root 10 plus root 2 to the power of 7/3 is what? Now, if you want, you could type this in your calculator. Luckily, this is a MCQ question, so there'll be answers. Option A is 24 plus root 5. Sorry, 4 times root 5. Option B is 24 plus 6 times root 5. Option C is 24 plus 8 root 5. Option D is equal 24 plus 10 root 5. And option E is 24 plus 12 root 5. Now, these are the 5 options that we have. Now, the common thing with all these numbers is they have the number 24 and root 5. However, they have different coefficients. When it says 4 root 5, it actually means 4 times root 5. So how do we go about this question? Now, let me show you one simple formula that you must know. If I have a to the power of n plus b to the power of n, it is equal to ab. Now I'm going to bracket this up because this is also to the power of n. For example, let's say n is number 2. A to the power of 2 plus b to the power of 2. Sorry, not plus, times. My bad. So, a to the power of n times b to the power of n. This can already make it a to the power of 2 times b to the power of 2. That will just be a square b square. I can just make it ab to the power of 2 because that will just make it a times b times a times b, which is still equal to a square b square. So how do we do this question? Now I'm going to slightly break down this answer. Root 10 minus root 2 to the power of 1/3 times root 10 plus root 2 to the power of 7/3 is equal. Now I'm going to break this down. Root 10 plus minus root 2 bracket to the power of 1/3 times root 10 plus root 2 to the power of 1/3 times root 10 plus root 2 to the power of 2. Now why? Now if I have 1/3 and 2, 1/3 plus 2 is equal 7/3. So this is just a to the power of 1/3 plus b to and a to the power of 2. I can easily plus this together. So if I have, for example, a to the power of 3 times a to the power of 2. This is already equal to a to the power of 3 plus 2 is equal a to the power of 5. This is the same thing I'm doing here. So it's a to the power 1/3 times a to the power of 2 is equal a to the power of 1/3 plus 2. Now, I can easily combine this together like what I wrote here, which is equal to bracket root 10 minus root 2 bracket root 10 plus root 2, which is and you break it up, you would factor to the power 1/3, then root 10 plus root 2 to the power of 2. Now, I can even go ahead and say this. Now, I have one more formula to show you. Where do I? Okay, here's space. A minus b to the power of a plus b. Now, a times a is a squared. Negative b times plus positive b is negative b squared. That's it. Why? Because negative b times a would also cancel out a times positive b. So this is just. Now I can already make this root 10. Okay, before we continue ahead, let's say let root 10 equal to a and root 2 equal to b. That way it'll make my life easier. So if I replace it, I can already have a square minus b square, and this is to the power of 1/3. Multiplied by, if I expand this, this will already become a square plus 2ab plus b square. Now, some people could ask whether I actually have to expand this further. Not necessarily. Now let's put this back into the values. Now, root 10 is a, so a square will be 10 square minus 2 square to the power of 1/3 times 10, okay, sorry, not 10 square, just 10, plus 2 times root 10 times root 2 plus 2. Now, what do I do after that? This is equal to 8 to the power of 1/3 multiplied by 12 plus 12 plus 2 times root, now root 10, where do I have space? Okay, one more. Now root 10, now if I split this up, if you press into your calculator, you notice that root 10 is actually equal to root 5 times root 2. So if I were to do this, this would equal to root 2 times root 2 times root 2 times root 5. Now, if I expand this, now 8 to the power of 1/3. So it's the same number times the same number times the same number is equal 8, which is equal to times 12 plus, now this root 2 and this root 2 actually make 2. So let me use a different pen. This 2 actually make root, sorry, not root 2, 2. So this is actually 12 plus root, that's 12 plus 2 times 2, 4 root 5, which is equal to 24 plus 8 root 5. This looks very similar to this, but that is the answer. Option C. Alright, now let's go to one last question. Alright, now this is also a senior round question. By the way, let me just put this up. Senior 2019 SMO question number 2. It's question number 2, if any of you are wondering. Now let's move to one last question. Okay, let's go down. Now this is senior round also, then this is question number. This is senior 27. This is question SMO 2017. Question number 5. The question is, simplify this root 5 to the power of third minus root 2 to the power of third, root 5 minus root 2 minus, same thing, but now I make it positive, root 5 to the power of third plus root 2 to the power of third, root 5 plus root 2. Okay? Now how do we solve this? Now, very simple. I am going to let a equal to root 5, b equal to root 2. Now, let's expand this. So it's basically a to the power of 3 minus b to the power of 3 divided by a minus b minus a to the power of 3 plus b to the power of 3 by a plus b. Now, in your school, you may have learned that I can easily make this one single fraction. How do I do that? Okay, I multiply a plus b here and a minus b. Now, if you go to a previous few minutes ago, you will notice I talked about a minus b times a plus b equal to a square minus b square. So I'm going to do the same thing here. This is equal to a square minus b square because I multiplied a plus b and I multiply here a minus b. So I easily have made this a square minus b square. But then I also have to multiply with the top. So that is already a plus b times a cubed minus b cubed minus, okay, here's the funny thing. Some people easily get confused with this minus. Now this minus actually applies to a plus b. So negative a and negative b. So that I can easily make, a minus b is applied here. So negative negative makes positive. So I can actually make this b minus a times a cubed plus b cubed. And this is equal to a to the power of 4 minus ab to the power of 3 plus a to the power of 3 minus b to the power of 4 minus a to the power of 4 minus ab to the power of 3 plus a3b plus b to the power of 4 divided by a square minus b squared. Now I do not want to actually put this back to original form because I will explain to you why soon. Now I'm going to do some cancellation. This a to the power 4 minus a to the power 4 is actually 0, so I cancel this out. Negative b plus b here, so I also cancel this out. Okay, now I am left with, well, oh, sorry, I forgot one more thing. This is actually negative a3b, sorry, my bad. Now, I am now left with negative ab minus ab cubed plus a cubed b plus a cubed b a square minus b square. Now I'm going to factorize this. What if I minus 2ab from all of this? What am I left with? I'm actually left with a square minus b squared. And I have a squared minus b squared. So actually, I can cancel this entire fraction out and this fraction out. And now I am left with 2ab. And if we put this back to original form, this is 2 times root 5 times root 2. So this is equal to 2 root 10. Alright, now I thank you for listening. Now I hope you have understood some things from this video today.